Hello, this is Mrs. Ward, and I am going to go over the notes for section 5.1, extrema on the interval. So the first thing we're going to do is we're going to understand the definition of what an extrema is on an interval. We're going to know the difference between a relative extrema and an absolute extrema on an open interval, and then we're going to talk about closed intervals as well. So first of all, a minimum is when the minimum of a function is the lowest y value. So I think that just makes sense, but I'm going to say f of c is a minimum, is the minimum, I guess I should say, if f of c is less than or equal to f of x in the interval, and then we'll have the interval a to b, so whatever interval that is. So f of c is a minimum if f of c is less than or equal to every f of x for all x's, I should say for all x's, in the interval from a to b. A maximum would be the exact opposite, would be f of c is a maximum if f of c, whoopsie, f of c is greater than or equal to f of x for all x in the interval from a to b. So I hope that makes sense. It should make sense. If you're the minimum, you're the lowest value, and remember f of c, or that would be your y value. So this is your y value. So when you're looking at the graph, it's the lowest point. When you're looking at the graph, it's the highest point. Should make sense. Oh, I do have to apologize for this here. I can't get rid of that. I'm recording from home, and we're just going to have to live with that. All right, the next one. So I do have two types of extrema, and one's going to be the absolute. And the absolute is for the entire interval. So the entire interval. So when I'm looking at the graph, it is truly the highest point or the lowest point on the entire interval. When I talk about a relative extrema, I think of a graph. So I'm going to think of this graph here, and I'm just going to do a graph. And let's say I start here. We'll make a closed interval. I go up and I go down, and then I go up again, and I stop here. A relative extrema is those bumps. So if I talk about a relative extrema, I'm going to have a relative extrema here. So if I think about riding like a roller coaster, it's like when you're going up and you're getting all nervous and you're going up, 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 and you hit that one instant where you're like not really going up anymore and you're not really going down anymore, and then all of a sudden you drop down, woo, when you're riding the roller coaster. Well, that is going to be a relative max. And the best way to think of that is if you go back to that roller coaster, as I said before, it's like that instant where you just stop moving. It's like you're not really going up anymore. You're not really going down anymore. You're just sort of hanging out in limbo. And when we think about that, and we're going to talk more about this later, that change in your speed is zero. So that's going to be when your derivative is equal to zero. And that's how we're going to find those relative max. And then down here would be like a relative min. And then if I'm looking at the entire graph, like this entire graph from this interval here to this interval here, this point here would be my absolute max. And then this point here, not only being a relative min, also in this interval would also be the absolute min. So let's talk a little bit more about that in a second, but let's talk about the extreme value theorem. So what the extreme value theorem says that if you are a continuous function, in other words, no breaks, no holes, no asymptotes, in the interval from a to b, then your function has to have both a minimum and a maximum on that interval. So somewhere on that graph, you're going to find the highest point and you're going to find the lowest point. That only works if your interval is closed, so you have brackets, or if I'm doing inequality notation, that would be like greater than or equal to, less than or equal to. You have to have the equal to parts of that sign. So let's talk about a function. So if I have this function f of x is equal to that, I am going to, if old school, if I were to graph that, I would do my intervals from -2 to 3. So -2, -1, 0, 1, 2, and 3. I'm just going to do the integers to save us some time. And when I put in -2, so that would be 4 minus 3, that's 1. Then this would be -2, -3, -2, 1, and then 9 minus 3 would be 6. So if I were to plot those points, -2, 1, -1, -2, 0, -3, here we go, plotting those points. I'm going to have this graph. And the reason why I'm doing this is I want to talk about like my extrema. I want to talk about my max and my min. I'm on a closed interval. And so I start at -2, -2 is included. I end at 3, 3 is included. When I look at this and I look for my lowest y value, my lowest y value is that -3, which is this point down here. My highest y value is this 6, which is this point here. So very simply, very easily, I'm going to say that this is my min, and it's going to be my absolute min, and then this is going to be my absolute max. And by absolute min, the absolute min is going to be -3, because you're going to use the y value. The absolute max is going to be that 6. It occurs at 0, it occurs at 3, but the absolute min is -3. The absolute max is +6. So let's look at another one. Oh, sorry. What is the value of the derivative of the relative extrema? Well, the relative, and I only have one relative, and that would be this one right here. This is the only relative one. This is a relative one, and it's an absolute. This one is just an absolute. Remember, to be relative, it's like you have to change direction. So here I'm going down, down, down. Then I go up, up, up. So I change directions. So this relative min, if I were to do this, my derivative at that point, the derivative of that function at that point would either equal 0, or sometimes the derivative at that point does not exist. So I cannot find the derivative. That would be like a vertical tangent line or something like that. So let's move on to the next one. So the next one says find the extrema when the to find the extrema, you find where the derivative is equal to 0 or undefined. You want to know that, memorize that, however you want to think about it. That's how I find the extrema, which I'm now going to start referring to as my critical numbers. Critical numbers, and we'll talk a little bit more about that later. So here it says find the relative extrema. So I'm only finding the relative extrema. I'm not looking for the absolute max or the absolute min. So to find the relative extrema, I'm going to set this find the derivative. So this would be 3x squared minus 3. To find that, there's not going to be a place where it's undefined because I don't have anything in the denominator. So I am going to set it equal to 0 to find out when my derivative is equal to 0. Remember, that gives me that horizontal tangent line that we talked about before. So here I'm going to add 3 to both sides, divide both sides by 3, and I'm going to get 1. Then I'm going to take the square root, so square root, and when I do that, x is going to equal plus or minus 1. So my relative extrema, or my critical numbers, which are the same as that relative extrema, are going to be when x is equal to 1 and when x is equal to -1. There is no place where I'm going to have a tangent line that is undefined, so I just have to find when the tangent line is equal to 0. Okay, here's the next one. I'm going to look for my critical numbers and my extrema values, my relative extrema. So what I'm going to do is I am going to take the derivative. So this is going to be -2/3 times the quantity of x minus 1, subtract 1 from this, and I'm going to have -1/3. And then doing the chain rule, take the derivative of what's inside, which would just be 1. So I didn't really have to do that, but I did. And now I'm going to get, in the numerator, I'm going to have that -2. In the denominator, I'm going to have 3 times the quantity of x minus 1 to the 1/3 power. So to look for my relative extrema, I'm going to set this derivative equal to 0. And I guess the best way to, when I set this equal to 0, so when my derivative, in order to set this equal to 0, that's only going to occur when the numerator is equal to 0. Well, my numerator is this -2. So this -2 has no variable, so it's never going to equal 0. So there are no places where I have a horizontal tangent line. There are no places where my derivative is equal to 0. Let's talk about where my derivative does not exist. So here, that would be a vertical tangent line. Or you can think of it as when your derivative does not exist. And that's going to happen when your denominator is equal to 0. So I'm going to take this denominator, 3 times the quantity of x minus 1 to the 1/3 power, and I'm going to set that denominator equal to 0. So divide both sides by 3, and I'm going to have x minus 1 to the 1/3 is equal to 0, because 0 divided by 3 is 0. To get rid of that fractional exponent, I'm going to raise this to the 3rd power, because 3 times the 1/3 would be 1, so I'd be left with just x minus 1. If I raise the left side to the 3rd power, I have to raise the right side to the 3rd power. Well, 0 raised to any power is always going to be 0. And then I'm going to add 1, so x is equal to 1. So I am going to have a relative extrema at x is equal to 1, or one of my critical numbers, my only critical number in this case, is going to be x is equal to 1. So now we're actually officially defining critical numbers. So a critical number is said to be when your derivative is equal to 0, or when your derivative does not exist. So that's what a critical number is. Derivative is equal to 0, or it's not, does not exist. It does not. That makes it a critical number. And if you have a relative min or a relative max at C, that means C is a critical number too. That's the only place critical numbers can take place, is when you're at a relative max, relative min, when your derivative is equal to 0, or when your derivative is undefined. So let's talk about this in great length. So here we go. So I have it says find the critical numbers in the interval from A to B. So that means I'm going to find when my derivative is equal to 0, and I'm going to find when my derivative does not exist or is undefined, however you want to word it. Then we're going to evaluate each of the critical numbers. So we're going to evaluate these, however many we have. We will definitely sometimes have more than one. Then we're going to evaluate the endpoints of A and B, and that's why it's important that's a closed interval, because that means I include A and I include B. The least of these numbers is going to be the minimum. The greatest of these numbers is going to be the maximum. That seems pretty straightforward. So here we go. I said find the absolute extrema of this function on the interval. So I want the absolute max and the absolute min. First thing I'm going to do is find my critical numbers. So I'm going to take my derivative, and that's going to be 12x to the 3rd minus 12x squared. I'm going to set that derivative equal to 0. When I do that, I'm going to factor out a 12x squared, because I think that would just be easier, and I'll be left with x minus 1 is equal to 0. Set both of these equal to 0, so 12x squared is equal to 0, x squared is equal to 0, x is equal to plus or minus 0, which is just 0. Then I'm going to have x minus 1 is equal to 0, so x is equal to 1. So I have two critical numbers. And from now on, I'm going to call critical numbers just Cn. We'll say Cn. And my Cn's, my two critical numbers, are going to be when x is equal to 0 and when x is equal to 1. So when I look for my absolute min and my absolute max of this function here, on this interval, I'm going to check 4 points. I'm going to check -1, 2, 0, and 1. So what I did is I put it in my calculator, and I did the such then, or you can do a graphing page, whatever you want, and I get these values. I get, let's see, I get 0, -1, 7, and 16. So now I'm just looking, what is the smallest number? Well, that's not too hard. This would be my smallest number. So my absolute min is going to be that -1. My absolute max is going to be the highest value, which is going to be that 16. And it's really that easy. That's all you really have to do. Hardest part is finding the critical numbers. So let's look at another one. Here I have the function f of x is equal to 2x minus 3x to 2/3. First thing I'm going to do is I have my closed interval from -1 to 3. I'm going to find the derivative. So when I find the derivative, that's going to be 2 minus, when I multiply that, that'll be negative 2x to the negative 1/3 power. I'm going to set that equal to 0. So 2 minus 2, I'm going to write like that, x to 1/3 is equal to 0, so that I have a positive exponent. I probably shouldn't have done that. I'm going to add that to both sides. So I'm going to have 2 over x to the 1/3. To solve this, I don't know how you want to think about it. I like to think that I'm taking that x to 1/3 out of the denominator, so I'm going to multiply both sides by that x to 1/3. Or some people prefer to go back and think of this as like, if I put this over 1, then I'm going to cross multiply. However you want to do it, I'm going to get 2 times x to the 1/3 is equal to 2. To solve this, I'm going to divide both sides by 2, and I'm going to have x to the 1/3 power is equal to 1. Then to solve that, I'm going to write that again. I'm going to raise both sides to the reciprocal power, so I'm going to raise both sides to the 3rd power. And when I do that, I'm going to have x is equal to 1, because 1 raised to the 3rd power is 1. So that's my critical number. That's when my derivative is equal to 0. But I have to be careful, because when I write my derivatives 2 minus 2 over x to the 1/3, which is the way I probably should have written it to start with, I see that I do have x in the denominator. So this will be undefined when x to the 1/3 is equal to 0. Raise both sides to the 3rd power. So x is equal to 0 raised to any power is going to be 0. So 0 is also a critical number. So my critical numbers are going to be 1 and 0. My interval is going to be -1 and 3. So I'm going to check all 4 of those points. So I again put that in my calculator. And when I did that, I got these values. And remember, you're putting it into the original function. You're not putting it into the derivative. Because if you put it into the derivative, you should get, well, you should definitely get 0 for 1, and you should get undefined for that one. So when I put it in, I have these values. I wonder why I didn't put in 3. And so when I, okay, I found my missing 3. So I did substitute in 0, 1, -1, 3. And the lowest value is going to be this -5. So that's going to be my absolute min. And then when I look for the greatest value, that's going to be the 0. So that's going to be my absolute max. And it's really just that easy. The hardest part, again, is finding the critical numbers. Make sure, especially ones like this, if you have something in the denominator, you got to set that denominator equal to 0 so that you find the critical numbers when your derivative does not exist. Okay, so this one, I'm going to locate the absolute extrema of the function over the interval. So it has different intervals from a to b or a to d. And when I look at this function, here's my function. And when I go from -2 to 2, I can see that it's going to be 0, 0. I can tell that my critical number is going to happen at 0, and I can tell that that's going to be 2. But if I didn't know that, I could find the derivative of that. So that is going to be this ordered pair, which is going to be 0, 2. So when I go to find the absolute max of this function, the absolute max is going to be that 2, the y value 2. The absolute min is going to be the 0, which is these guys. It occurs here at +2, and it occurs here at -2. When I look at the next interval, the interval's changed, still same function. I'm going from -2 to 0, but I have this parenthesis here, which means I do not include the 0. If I don't include that 0, then I lose that maximum point. So when I say absolute max, I'm going to say none. I don't have one, because I'm approaching 2, but I'm not going to hit a definite max number. My absolute min, because I'm still including this point -2, I do have a min of 0. On this one, I'm doing -2 to 2. This is an open interval where these points are not included, but the 0 is. So I still have an absolute max of 2, but when I go to find my absolute min, since those points are not part of my interval, I'm going to say none. And then the next one, I'm sort of chopping my interval a little bit, and I'm going from 1 to 2. So let me bring this guy down here. I'm going from 1 to 2. So 1 would be here to 2. Well, I know my absolute min is still going to be that 0. To find my absolute max, I'm going to put 1 in here. So I'm going to have the square root of 1 minus, oh, I'm sorry, 4 minus 1 squared. So the square root of 3, which ends up being, you can write the square root of 3 or you can write 1.7. And that would be your absolute max because I'm only doing the interval from here to here. So that one would be my new endpoint, which would give me a different max. Okay, moving on. I had a nightmare that way. Okay, the next one, I'm looking at this. It says, how many relative extrema does the graph have shown? So relative means that it's not going to be, it doesn't necessarily have to be an absolute or absolute max or an absolute min. It's that place where the curve sort of changes directions. You have like a bump in the curve or a point in the curve. So this here would be a relative min. And I'm going to say it's a relative min because in this area, I'm going down, down, down. I hit a low point and then I start going back up. So that makes the relative min. This point right here would be a relative max. Again, different reason because I'm going up, 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 hit it like a peak, and then I start going back down. Here is a relative min. When I'm looking for a relative max or relative min, I'm looking for the place where the graph changes the direction. So I'm not going to look at these endpoints because they are not going to be a relative. They're going to be, they might be an absolute, but they're not going to be a relative. Then it says, how would you classify them? Well, this is a relative max. By no means is it the highest point on that graph. This one here is a relative min. Again, not the lowest one on the graph. This one down here is kind of special though, because not only is a relative min, it also is, if I draw a horizontal line at that point, that is going to be the lowest point on that graph. So not only is that going to be a relative min, that is also going to be an absolute min. So I'm going to say absolute min as well. So relative max only, relative min only, both relative min and absolute min. And it's important that I distinguish between, it's important that I know that it's a relative min as well as an absolute min, because at a relative min, I know that I have a critical number there. That's part of the definition. If you have a relative min or a relative max, you have a critical number. So that tells me a lot about the derivative of the function. So I need to know that it's not just an absolute, that it's also relative. Example 7 says, give an example of a function that would not have a minimum or a maximum on the closed interval 2, 9. So I think of let's say I had f of x was equal to 1. Well, that's a horizontal line at 1. On the interval from 2 to 9, I'm not going to have a max or I'm not going to have a min because every value is going to be the same. So that would be one example, any horizontal line. The other thing I can think of is, and it doesn't tell me that it has to be continuous, I think of something like 1 over x minus 5. Let's say that was my function. Well, when I hit that 5, when I graph this and I hit 5, I should realize that I am going to have a vertical asymptote, which means I'm not going to hit a relative max. I'm not going to hit a relative min because this one's going to keep on going up. This one's going to keep on going down. So anytime you have a vertical asymptote in that interval, you will not have a max or a min. But again, that's not a continuous function either. So let's remember that. All right, number 8, I just want to make sure that we are crystal clear on this because we talked about it in chapter 1. We didn't really talk about it in chapter, I should say chapter 3. But we're finding the value of a derivative at the extreme of 0.45. I can definitely see that 4.5 is, it's a relative max. I see that. This is a relative max. I know because it's a relative max that that 4 is a critical number. But the reason why the 4 is a critical number, and I want you to make the distinction by this, is I have a choice. Either my derivative could equal 0 or my derivative could not exist. In this case, my derivative does not exist. So what is the value of the derivative at this point? The derivative does not exist. There is no value for the derivative. And the reason for that is if I were to look at the slope of this line, because remember derivative is the slope of the line, if I were looking for the slope of the line at that point 4 or 5, as I'm approaching from the left, remember that whole limit thing as I approach from the left? That looks like my slope would be a positive 1. If I'm approaching that 4 or 5 from the right, oh, that would be a negative 1. If I'm approaching 4 or 5 from the right, no, I was right the first time. My slope would be a negative 1. This one would be a positive 1. Why don't I just trust my gut? So this would be 1. So since they don't approach the same number, in other words, the slope is so drastically different, it goes from 1 to negative 1. That means my derivative does not exist. That is completely different than if you have this nice rounded curve like that. Because here, if I'm drawing my tangent lines, and I don't know that I can do this, my tangent lines will slowly, to eventually I get a tangent line of 0, and then they'll start going down. So this derivative does exist. This derivative will be 0 here, but this derivative, that sharp point, and anytime you have a sharp point, the derivative does not exist. I just wanted to make sure we understood that and we knew that. So I thought I'd throw that in there. All right, I hope this helps, and I will see you next time.